All right, so today we're going to do the first derivative test. Next time we will do the second derivative test. So it's what the first derivative tells you about what the function is doing. So first we're going to talk about critical points, which we have already, but we're just going to write it down again. This is where your derivative is 0 or undefined, which I feel like maybe put like some stars or underline that or something, because I feel like we do derivative equals 0 so much that we tend to forget it's also where the derivative is undefined. Do you remember your absolute value graph? How there's that sharp edge there, not differentiable due to sharp edge, but that's still a critical point. It's where you have a relative minimum. So undefined still counts. So these are your candidates for locations of relative extrema. And I have to be really careful about how we say that. It's a candidate, meaning it could be or it could not be. Do you remember the cubic function, like your parent function x cubed? How at 0 you have a critical point, it goes horizontal, but that's not a place where you have a maximum or minimum. So it's a candidate, it could be. And then location of. This is huge, and people mix it up all the time, and they will not give you credit on the AP exam because they're super picky. The x value is not the maximum or minimum. It's just the location of it. Do you know how we write them like 2 at x equals 5 or whatever it is? The 2 is the actual answer. The at x equals whatever is just the location of wherever it is. So just be careful how you say stuff, okay? So your first derivative test says, if f prime, and you always, this is like citing your source. I always bring it up, like, how whenever you like quote somebody or in a bibliography, you're like citing your source. F prime is your source. Okay, that's what you're citing. If f prime changes from positive to negative, I'm going to tell you, but I want to see if you know what happens if your derivative changes from positive to negative. What does that mean your graph has? Positive to negative. Well, a critical point will be like an x-intercept on the derivative graph, because it's where that would be 0. But if you have positive and then negative, relative maximum, good. Well, location of relative maximum. All right, location of relative maximum. Because positive to negative means if the derivative changes positive to negative, it means your actual function changed from increasing to decreasing. So if it goes up and then goes back down, you end up with like the peak of the mountain there. And then here's, I call this the sibling statement. It's going to be the exact same thing, but I'm going to change it. If the derivative changes from negative to positive, then that is the location of a relative minimum. So like, again, as a heads up, you're going to write a little bit today because we're going to practice all these justifications, but I just hammer them into everybody. And then when you get to the AP exam, it's just like, you've practiced it a zillion times and it's just, you can write them. Okay. And then this is our little chart. We'll add on the third column. Do you guys remember this chart? I love this chart. We'll add on the second derivative next class when we do the second derivative test. But where your original function is increasing, your first derivative is positive. Decreasing means negative. And we did that back whenever we were graphing the derivatives. Remember how I highlighted them different colors for increasing, decreasing? We color coded it. Okay, thank you for heads nodding. Then I gave you envelopes with them in and you matched them all up. Yeah, same information. Okay. So state the intervals of increasing, decreasing, and the relative extrema. That's your maximums, minimums. Justify means write a sentence. I get that word justify can be kind of scary. We'll get through it together. So the first thing you have to find is your critical points. So it's going to be derivative equals 0. So this derivative will be what? 3x squared plus 6x, good, set it equal to 0. And then that was the calculus. Here's the algebra. You have to factor that. So what can we factor out? 3x. You'll be left with x plus 2. And so your critical points are, what are you going to get if you set each of these equal to 0? Yep, 0 and negative 2. So listen, those are critical points, period, end of story. Whether they cause a relative maximum or minimum is still yet to be determined, but they are critical points no matter what. just for foreshadowing, we're going to talk about inflection points next time. Do you remember inflection points with the second derivative test? No? Okay. Critical points are for the first derivative. Inflection points are for the second derivative. These are critical points no matter what. The inflection points, you have to actually have a change, okay? These are still critical points though, no matter what. So what I always do is make a number line. I'm going to make a number line for each one of these factors. So for the 3x and then for the x plus 2. Now, they don't read number lines on the AP exam. They will treat them like they are not even there. They will read your sentences. But here's the thing. You need the number lines in order to correctly write the sentences. And it only takes a second to fill these out. So like, just do it. Okay. 3x, that gave us the 0. X plus 2, that gave us the -2. Now, you want to put them on there in order left to right. It's a number line. Negatives come before 0. So put the -2 first. Now, unless anything weird happened, and what I mean by weird is throw a negative in there, or something was backwards, or something was squared. You're going to know. You're going to be like, huh, that was weird. If nothing weird happened, it is going to be negative and then change to positive at the critical point. If nothing is backwards, or nothing is negative, or nothing strange happened, it's going to be negative and then turn positive. So same thing with this one. Now, if you didn't like that, or if you're just like, I don't trust you, you can pick a test point. Here, I'll show you. Let's do this one. Give me a number to the left of -2, something that would be over here. -4. If you plug -4 into this, you would get a negative result. See what I'm saying? Give me a number bigger than -2. 2. 2 plus 2 is 4. That's positive. Like, you can always pick a test number. And then what I do is I slice up the number line. So I'm going to slice this here at -2. I always call these little balloon strings. They look like little balloon strings on there. And then we're going to write what the overall sign is for the whole thing, because we did each factor separately. Now we're going to put it all together. So look at this first section. Negative times negative, be positive. So this section is positive. The middle section is negative, and then a positive times a positive is positive. So we're going to use that to write all of our sentences. Okay, so buckle up. We're going to write a little bit here. Okay. Now we're talking about the original function. So it's going to be f of x is, or f of x has. Like f of x is the noun of your sentence. It's like very much like English class here. So we're going to say something about f of x. F of x is increasing on what intervals? Look at your number lines. From where to where and from where to where? Looking at this. Good. Negative infinity to -2. Union, where else? 0 to infinity. Because, so here's the justification. Cite your source. Your source is the first derivative. Because f prime is what? Why do we pick those two? Positive. There. So that's your first sentence. The function f of x is increasing on those intervals because derivative is positive there. Now we're going to write the sibling statement. Let me like kind of bullet these. F of x is decreasing on what interval? -2 to 0, because, cite your source, it's the first derivative, is negative there. The exact same statement, but just the opposite. So you want to start out with f of x is, then we're going to do the relative extrema, the relative maximums and minimums. This would be f of x has. F of x has a relative maximum at x equals, it's at that location, at x equals. Where is the maximum going to be? At -2 or at 0? Which one of these gives us a maximum? Good. X equals -2 because, and then why is it this one? And cite your source. It's because the first derivative does what? What does the first derivative do there that tells us that? Goes from positive to negative there. F prime changes from positive to negative there. Sorry, I kind of ran out of room. As an aside, I would accept on the test, some people will do this. They'll say from, and they'll just put a plus sign to negative there. I'll take that. They won't on the AP exam. So make sure, they'll take an abbreviation like POS for positive, but you can't do that. Does that make sense? Like you have to at least abbreviate the word. All right, and then let's do our sibling statement here. Last one. F of x has a relative minimum at what? At x equals 0. Good. Because who's our source that we're citing? It's like your bibliography. First derivative. It's the first derivative test. You have to cite the first derivative because first derivative changes from what to what? Negative to positive there. There, you survived writing the sentences. Good job. So you want to start your sentence with f of x is or f of x has and cite your first derivative. It's the first derivative test. We're going to do the same thing with this one. I won't make you write out every sentence. We'll just do it verbally, okay? But what is this the graph of? What were you given? Look at what you were handed. That is the derivative. We're going to write sentences about the original function, not the one you're looking at. Do you get what I'm saying? Okay, they usually do that. They ask you questions about f of x, but they don't give you f of x. They give you f prime. Okay, so we're going to do the same thing. F of x is increasing wherever the first derivative is positive. You are looking at the first derivative. So where is this graph positive? I'll color code here. Where is this graph positive? Good, above sea level. So 0 to 2, where else? Good, 4 to infinity, perfect, all right? So increasing 0 to 2, union 4 to infinity. I won't make you write it, but what would be the because statement? Because why? Because first derivative is positive there. Good, all right? F of x is decreasing, and I'll make this one green, so below sea level. This one looks like, actually looks like a sea serpent a little bit. All right, so decreasing would be on what intervals? Negative infinity to 0 and 2 to 4. I won't make you write it, but we'll just do it verbally. What would be the because justification? Because is negative there. For f prime is negative there. All right, and then we're going to do the same sentences for the relative maximums and minimums. F of x has, make sure it starts out like your noun is f of x, your verb is or has. F of x has a relative maximum at x equals. Now, maximum would be a change in the first derivative from positive to negative. So that would be a change from above to below. So actually, I went ahead and wrote that. I'm not sure. Oh, we do have one. Where does that happen? Where we change from above to below? At 2, do you see that there? Above to below. And your because statement would be because what? That part's not going to change. Do you know what I'm saying? Like even on your test, that's the answer. Like that is the answer. I can't change it. It's like a definition. And then f of x has a relative minimum at x equals, I feel like there might be 2 of these. Minimum would be changed negative to positive. So that would be below to above. Yeah, we have 2 of these. Where are they? Good, 0 and 4. And it would be because f prime changes from negative to positive there. Now we have to write one more statement. There's one more critical point, and you have to address that. Where is the other critical point? Because we did 0, 2, and 4. Where's the other one? 7. F of x has neither a relative maximum nor minimum at x equals 7. And we will write out the because statement for this one because we didn't do one like this in the previous question. F of x has neither relative maximum nor minimum at x equals 7 because, now you're still citing your source. Your source is still first derivative. Because first derivative, and what would you say? Like, why does that not cause a maximum or minimum? Yeah, you can, okay, you each said one of the 2 ways you can say it. You can say f prime remains positive there, or you can say f prime does not change sign there. Either one of those is acceptable. F prime, I usually go with does not change sign. Only because like here it would be remains positive, but what if it was below? Then it would be remains negative. So I usually just go with does not change sign there, and that covers all the time. This is huge though. They love to give you this on the AP exam, to give you the derivative graph and then ask you these questions. It almost always shows up on the free response and you can just nail it. Like you can just get all the points. Like those are the answers. This looks super tired. Are you with me? It's because I like this material because I feel like you can get a lot of points for this on the AP exam. And it always shows up. So those we were doing increasing and decreasing in the relative extrema. This says absolute. Now we talked about this with extreme value theorem last week, right? Absolute means you're going to do the candidates test, where you make a little table and you test all of your candidates. So who are your candidates? Good, perfect. Critical points and endpoints. This will show up in the AP exam, 100% guaranteed. Sometimes there will be 2 of these on one exam in 2 different free response questions. I've seen them do that. This is like going to show up on it. All right, so here's our function. This is our interval. So those are our endpoints, -2 and 1. We just need to go find the critical points. I'm going to pause the recording. I want you, like with each other, you can, I got this. What did you get? Compare. I want you to find the critical points. So here's our derivative. We are going to have to factor that, but like, what do you notice goes into each of these? 6. So if you divide through by 6, that'll make the numbers a little smaller. So it'll be 2x squared plus x minus 1 equals, what's 0 divided by 6? 0. I just divided through by 6. 0 is great that way, like 0 is not going to change. So we're going to factor that. 2x squared will split 2x and 1x. 1 will split 1 and 1. You want to end up with a positive 1x in the middle. So like what symbols are we going to need? Yeah, good. Negative here and positive here. Good. So I got 1/2 and -1. Is that the consensus? Okay, sweet. So when you make your table, you are plugging into the original function. You want the actual functional value. So it's x, f of x. And then I guess you can put these on there in whatever order you want, but like for the love of my sanity, can we put them in order? Like here's our endpoints. Here's our critical points. So like I'm going to put them in numeric order. So -2, -1, 1/2, and then 1. Every once in a while, this is kind of nice when this happens, you'll get a critical point that's not in the interval. So what do you do with it? Yeah, nothing. Just throw it, like less work for you. Okay. So we're going to plug those into the original function. All right, here we go. This is where we're going to have to fight through this. And usually it's non-calculator. So here we go. -2 cubed. -8 times 4, -32. I'm going to write out the middle step here because that's a lot to do in your head. -2 squared would be 4 times 3, be 12. And then -6 times -2 be positive 12. So that's -32 plus 24. -8. All right, let's do the same thing with -1. If we plug in -1, that's going to be -4 plus 3 plus 6. So what is that, 5? 1/2. Okay, here we go. 1/2 cubed. Well, 2 cubed is 8, so 1/2 cubed is 1/8 times 4. So 4/8 be 1/2. Okay, that wasn't too bad. We made it. 1/2 squared be 1/4 times 3. That would be 3/4. And then -6 times 1/2. That would be -3. All right, let's see. 1/2 would be 2/4. I'm just going to change that so that we have a common denominator. So what would that be? 5/4. Actually, let's change this to fourths as well. How many fourths would 3 be? Be 12/4. So what is that? -7/4. Good enough. Almost -2. Those fractions didn't seem to bother you. That's good. Usually fractions scare over it. All right, and then if we plug in 1, we're going to get 4 plus 3 minus 6, which would be 1. So, okay, that is a lot of work, but then you just write out your answer. Which one is the biggest? Literally, all you have to do is which one of those came out largest? 5. Okay, absolute max is 5, at x equals -1. You don't need to put a because justification. Do you remember why? We don't have to put because for these. The chart is your justification. You tested every single candidate and like that one's the, because what would you say? Because 5 is bigger than all the rest of these? Like you don't have to write anything. Absolute minimum is, all right, which one came out smallest? -8 at x equals -2. And that's your answer. You don't have to justify it. I love candidates test. You just test all the candidates. The fractions got a little weird in there, but test your critical points, test your endpoints, write your answer. Boom. It will show up on the AP exam, like 100%. It will be on there. This one, we're just going to practice one more. Only thing is, do you see what you're not given in this problem that you were up here? You don't have an interval, so there aren't any endpoints. You need to show that you examined the entire real number line, -infinity to +infinity. Okay, so it's a little bit trickier to write, but sometimes they do this to you. So I want to make sure you got it. We're still going to start by finding the critical point. So it's derivative equals 0. Derivative would be -2x minus 4. Set that equal to 0. So add over the 4, we get x is -2. So we get to there, critical point? Okay. Usually, like if it's the free response part, you would get a point for finding the critical point. So you'd have that. Now I'm going to make a number line for that. So my -2x minus 4. Now, are you like, hey, wait, something weird happened. Do you see that negative out front? Remember how I said if nothing weird happened, it's negative and then it turns positive? But aren't you like, hey, wait, hold on a second. Let's pick a test number. Give me a number over here, like a number to the left of -2. Let's do -3. -2 times -3 would be 6. Minus 4 is 2. That's positive. If you pick a number over here, like 0, if you plug in 0, you're going to get -4, which is negative. So first of all, here's this question. Do we get a maximum or do we get a minimum there? Maximum. And I always do that too. No, just do that while you're taking the AP exam. So maximum. But writing why it's now that would justify that it's a relative maximum, but absolute means you need to show you like examined the entire real number line. So we're going to say absolute maximum. Oh, and here's another common mistake. People will say the absolute maximum is -2. It's not. How do we get the actual answer? What do we have to do with -2? To plug it back in. That's just where it's located. It's the point -2 comma something on the graph. So plug in -2. -2 squared would be 4, only it's negative, so -4. And then what would that be? +8, so 4 minus 7 would be -3. Absolute maximum is -3 at x equals -2. Because, now how can we justify that it's absolutely the biggest? Like it's a relative, like this goes up and comes down, but how do we know that it is the peak? Like why does that have to be bigger than every single other point? Because it is what critical point? It's the only one. There's not another option. It's kind of like an only child. Do you get what I'm saying? Because x equals -2 is the only critical point. And here's where you have to show that you thought about the whole number line. You thought about every number in existence. That's what they want you to do. So what is going on for this interval? Derivative is positive. And f prime is positive for -infinity to -2. And f prime is negative for -2 to infinity. And what that does is that shows you thought about -infinity to +infinity. You thought about the whole number line, and that has to be the biggest one. This does not come up as often. I've seen it, so I cover it, but this is what is much, much more likely to come up is that you will make a table. Okay. All right, so that was your first derivative test. When we do optimization, it is the first derivative test. It's literally the exact same thing. Optimization means find the optimal value, which optimal we think of like as a maximum, but it could be a minimum. Like the optimal cost would be a low cost, right? Like you'd want to lower your cost or, anyway, maximums and minimums is what we're finding. That's what we just did with the first derivative test. So your steps for optimization. First, you want to write an equation for what is being optimized. Because oftentimes in these problems, there's several things going on, but you want the equation for whatever is being optimized. So if we want the minimum cost, you want an equation for cost. If you want the biggest volume, you want an equation for volume, like whatever you want that's to be the biggest or smallest. So write an equation for what is being optimized in terms of one variable, which oftentimes involves having to substitute something. Do you remember the one from the quiz that we just went over and we had to substitute out the radius? We had to get rid of that, so it was just height. Same thing here. You need to do some algebra so that it's only one variable. And then how do you get critical points? What did we just do on the other piece of paper? How do you get a critical point? Derivative equals 0. That's it. Derivative equals 0. Critical points are what give you the maximums and minimums. So this is like algebra, one step of calculus, and then you get your answer. They're almost not calculus problems. Like the derivative is the only part that you do that's calculus. The rest of it's algebra. So here we go. Two numbers have a sum of 20. So if you add them up, they add to be 20. What is their maximum product? Product is the thing that we want to optimize. I'm going to use P for product. Hey guys, what's product mean? Multiplying. Can I call the numbers X and Y? Is that okay with everybody? You can use A or B, you can use whatever you want. I usually just go with X and Y. So we're going to multiply them. Here's the issue. That's two variables, X and Y. So I need to get rid of one of them. And that's like, okay, back to the problem. What else did they tell us? Yeah, what does sum mean? Addition. If you add them, you get 20. It really doesn't matter which one we solve for. We just have to get rid of one of them. Do you want to solve this for X or Y? It does not matter. Will not make a difference. We'll get Y by itself. All right, so subtract over the X. And you're going to take that 20 minus X and substitute it in for Y. So we're going to remove Y and replace it with 20 minus X. Yay! Now it's all just X's. Before I do the derivative though, what would you probably want to do with this X out front just to make your life a little bit easier? Yeah, like I would distribute that because otherwise you're going to have to do a product rule. So if you distribute that 20X minus X squared, and then P prime, find it. That was all algebra. Now we're going to do the derivative. This is your one step of calculus, all right? What is the derivative? Minus 2X, good, set it equal to 0. I kind of ran out of space. What would X be if you solved that? 10. X is 10. Not done though, because it says what is the maximum product? So if X is 10, what's Y? They add up to 20, so 10. And so what's the maximum product? 100. Does that make sense that they're both the same number? Because that's what's going to give you a maximum. The best rectangle or the most optimal rectangle is a square. Okay, so for example, if I said two numbers have a sum of 16, what's the maximum product? Because what are the two numbers? If they sum up to 16, 8. 8 times 8 is 64. Those are like no word questions, okay? Same thing with this one. A rectangle has a perimeter of 48 feet. What is its maximum area? The most optimal rectangle is a square. So if it's a square with a perimeter of 48 feet, what is each side going to be worth? Yeah, they're all 12 feet, right? So what's the area? 144. Now, units a little trickier for that one because it's area. So it's 144 feet squared. Now I mixed it up in number 3. The best rectangle is a square if everything is nice and neat and makes sense. If you throw a wrench in it and something turns out different, then you are going to have to actually do the problem. Womp womp, okay? What would be the maximum area? Same thing from number 2. So our perimeter is 48 feet. If you only needed to create 3 of the sides. So if like you're fencing in something that's like against a wall that's already there or something, you get what I'm saying? Like you like have one of the sides already, so you only need to do 3 of them. Well, that changes it. That's not going to be a perfect square anymore. Okay. So we want to maximize the area. Area would be length times width, which would be x times y. And the problem is there's an x and there's a y. You have to get rid of one of them. So again, what was the perimeter? What was our perimeter going to be from the previous problem? Get 48, and then good, it would be x plus 2y equals 48. Now, technically, it doesn't matter which variable you solve for, but which one would make more, like, which would be easier here? Which one would make more sense to solve for? Like, to get by itself. X, because it doesn't have a coefficient with it. So you would subtract over the 2y, 48 minus 2y. You're going to take that and substitute it in for x. And then it's literally just like number 1 that we just did. Area equals, in place of x, you're going to put 48 minus 2y. And again, before you do the derivative, you probably want to distribute that y so that you don't have to do a product rule. It'll be 48y minus 2y squared. So what's our derivative? Perfect. Equals 0. So you would add over the 4y, divide by 4. Y would be 12. But x would not be 12. It's not going to be a perfect square. Let's figure out what x would be. If y is 12, and you can either like look at the picture and go, hey, this is 12, and figure out what x is, or you can use, like, if you're more an algebraic person, if y is 12, look, 2 times 12 would be 24. 48 minus 24 would be 24. Like, it's twice as long as it is wide. Is this making sense? Okay. And then your area, you would have to multiply those together. I'll be honest, I don't know 12 times 24 off the top of my head. Does anyone know that? Is that what it is? It is, nice. So 288 square feet. Oh yeah, that's a good point. I hadn't thought of that. Right, because this is 2 squares, right? That are 12 by, oh yeah, that's good. That makes sense. 144 and 144. I had never thought of that. We're going to need a calculator at some, oh yeah, you know what? We are going to need a calculator for this one. All right, this one is a very famous calculus problem. I don't have time, unfortunately, for us to cut out boxes. You're going to have to just use your imagination. But you're going to use an 8.5 by 11 piece of paper. That's like a piece of paper like what we're writing on. So go ahead and draw yourself a rectangle. This is your 8.5 by 11 piece of paper. And what you would do is you would cut squares out of the corners. So like this part, this part, this part, and this part would be gone. Like if you cut that out. Oh, yeah. And then what you would do is you would fold the sides up to create a 3-dimensional box. Are we able to visualize that? Like, I should have made one. Like if you cut the squares out, like this side will fold up and this side will fold up and you end up with a 3-dimensional box. Anyway, we want to maximize that volume. We want to make the biggest volume box. So you need an equation for volume. How do you get the volume of a box? Good. Now the length was 11 inches, but you cut some out of each side and we don't know how much. So let's call that X, okay? So you cut X amount here, you cut X amount here. So what's left for this part? Like, how would we call that? Good. Length is 11 minus 2x, because you cut a square out of each side. And then this side was 8.5 inches, but again, you cut X out of each side. So how can I write that one? Yeah, 8.5 minus 2x. So that's length times width. Now, lastly is the height. If you take these and you fold them up, what ends up being the height of the box? Yeah, X, good. Like the height just is X. And here's the good news and here's the bad news. The good news is that's all just X, right? Like we don't have to do a substitution. So yay. Bad news is we have to multiply that all together. But more good news, you have a calculator? All right. So we're going to distribute all of this to each other. So 11 times 8.5, what is that going to give us? I don't have that memorized either. 93.5. All right, so the outsides would give you minus 22x. The insides would give you, what would that be, minus 17x? So minus 22 and minus 17 would be minus 39x. And then negative 2x times negative 2x would be what? Good, plus 4x squared. And then times x. And you're just going to distribute that through there. So it'll be 93.5x minus 39x squared plus 4x cubed. Here's the most common mistake I get, because I usually throw one of these on the test. I'll just, instead of 8.5 by 11, I'll change the numbers. People go and set that equal to 0. If you do that, you skipped the most important step. You skipped the only thing that's calculus. What do you have to do? Please don't forget to take the derivative. It's the only thing that's calculus, all right? So this derivative would be what? 78x, good, plus 12x squared, perfect. That's what we're gonna set equal to 0. Now here's why you need the calculator. That doesn't factor. Like, you know how you would usually just draw your parentheses and split it apart? That's not going to factor. So what we're gonna do is use the calculator. So go ahead and go to y equals. If there's anything in there, clear it out. And you're gonna type that in instead. And I would hit zoom 6. If I'm not given a window, I always choose zoom 6 to start out with, because 6 is standard. It'll put it back to negative 10 to 10. In case someone else was using the calculator and the window is really weird. But you should get a parabola because it's a squared. Something like this. All right, here's the problem. There are 2 critical points. Do you see that? One right there and one right there. Which one do we want? Well, we wanted to maximize volume. Maximums would be where the derivative changes from what to what? Maximum. Positive to negative. So that would be this one. Do you see how above to below? That'd be this one. Okay, now that we've decided we want that one, how do we get the calculator to give us this number? It looks like it's between 1 and 2, but I need to know exactly what it is accurate to 3 decimal points. Trace, okay, second trace. And then which choice on the menu do we want? 0. Now it's gonna ask you left bound, right bound, guess. Here's the easiest way to do that. You know how it looks like it's between 1 and 2? For the left bound, hit 1, enter. For the right bound, hit 2, enter. And for the guess, I'm just gonna do 1.5, but if you do anything in between them and then hit enter, because then you don't have to mess with the arrows. Do you know what I'm talking about? Like hitting those buttons, that always frustrates me. I just do it manually. Did you get 1.585? Yes. Okay. So x equals 1.585 inches. What that means is you should cut 1.585 into each side to get the maximum volume. What is the maximum volume? Here's the really cool thing that the calculator does. Watch me do this and then I'll have you repeat it. As of right now, and unless I mess with the graph anymore, it stored x as this value for you. Isn't that so nice? So nice. So if you quit out of there, and where do we want to plug this back into to get the volume? The original one. If you type that original thing exactly like it looks, it will plug that number in for x, that 1.58 whatever. It'll plug that in for x for you. So just type it exactly like it looked there. And right now, unless you messed with something else, the calculator has x stored as that answer, and it will plug it in for you, which is so nice. Unless you mess with the graph again. Like, unless you did another calculate 0, then it would have that one stored. Like, if you mess with it, you need to do it kind of like right away so you don't mess with it. All right, so did we get 66.148? It's not inches, it's inches cubed. Good, because it's volume.